This will be for the con-assignment probability models. Anna, Irina, Avel, and Vlad are going on a road trip. The following table shows an incomplete probability model for who will be driving during any given kilometer. What is the probability that Avel will be driving during any given kilometer? Okay, so basically, one person has to be driving. Okay, so the sum of these fractions has to be 100%. And of course, in terms of a decimal, 100%, when you move the decimal over two places, is just 1. All right, so the sum of these fractions has to be 1 because someone has to be driving. All right, so let's add them up. We have 1/8. We have 3/8. We have the question mark. And we have 1/8. And that has to equal 1, or 100%. Okay, luckily they gave us a common denominator. So we have 1 plus 3 plus 1, which is 5. And the common denominator is 8 plus question mark equals 1. All right, subtracting 5/8 from both sides. Okay, in case this cancels right here, in case you don't see it, 1 is the same as 8/8. Because the same number over itself is just 1, and this is minus 5/8. So the reason I did 8/8 is to get a common denominator with the 8. And of course, 8 minus 5 is just 3. And we still have the denominator of 8. So that's it. And that is answer B. So I'm pretty sure for all of these, they're going to add up to 100% or 1. Okay, Delia owns a gravel pit. She took a random sample of rocks and counted 58 sedimentary, 213 metamorphic, and 522 igneous rocks. Use the observed frequencies to create a probability model. Input your answers as fractions or as decimals rounded to the nearest hundredth. Okay, in most, if not all cases, the fractions are going to be better. All right, so you want to get the total. All right, the total number of rocks is going to be 58 plus 213 plus 522. And that total is going to equal, let me do it on the calculator, 793. So that is going to be the denominator in each of these answers. Okay? So I am going to put slash 793 for each answer. And that is only part of the answer, because that is just the denominator. Okay? Now for the sedimentary, there were 58 of those. So that goes in the numerator. And for the metamorphic, there were 213 of those. So that goes in the numerator. All right. And finally, for the igneous, there were 522. So that goes in the numerator. All right. So when you add these up,
Immaculate Conception.
So these always have to add to 1 if you want to check your work, okay? Obviously, since all the denominators are 793, the numerators have to add to 793 as well to get the total equal to 1. All right, Manny, Rochelle, and Peg race each other in carts. There are no other racers, and exactly one racer wins. No ties allowed. The following graph shows an incomplete probability for who will win any given race. All right. So again, these have to add to 100% or 1. All right. If we look at the probability that Manny wins, that is 0.35 or 35%. All right. We'll keep it in terms of a decimal. So I'm just going to write 0.35 for Manny. And for Peg, the probability that Peg wins is 0.25. Okay, so they want to know the probability that Rochelle wins. So the sum has to equal 1. All right, so we have 0.35 plus the question mark plus 0.25 equals 1. Okay, 0.35 and 0.25 is 0.6, or you can say 0.60, same thing, plus the question mark equals 1. Subtracting 0.6 or 0.60 from both sides cancels here, and that is going to be 0.40 or 40%. So you just make sure they add to 1, okay? Because like it said, somebody has to win. So 0.40, that's the same as 0.4. So these are all very similar, okay? These people are sharing a basket of fries. The following table shows an incomplete probability model of who will eat the next fry. Okay, I did one like this already, but it was fractions. So just make sure that the sum of these equals 1, because that represents 100%. All right, somebody has to equal the fry. So the question mark is just going to be 1 minus the sum of the other ones, 0.3, 0.1, 0.32, and 0.1. Okay, 0.3, 0.4, 0.5, 0.82. 1 minus 0.82 is going to be 0.18.